The speed of light is the absolute physical limit of our reality, clocking in at 300,000 kilometers per second. But when we zoom out to the scale of the cosmos, light might as well be crawling. Take humanity's fastest object, the Parker Solar Probe. Even tearing through space at hundreds of kilometers every second, it would take this machine 1,500 years to travel just a single light year. This animated diagram shows why scientists rely on the light year. It sounds like a measure of time, but it is strictly a unit of distance. It represents the space light covers in one Earth year, roughly 94 trillion kilometers. Astronomers use this massive unit to make cosmic math workable. Let's break the laws of physics. Imagine we build a warp drive capable of traveling 1 light year every single second. What light takes an entire year to cross, you will cross in the time it takes to snap your fingers. Now strap into this machine and set a timer. You have a standard human lifespan of exactly 60 years to fly. Traveling at 1 light year per second, how much of the universe can you actually see before your clock runs out? The clock starts. At this speed, you clear the entire solar system in exactly 1 second. 4 seconds later, you fly past our nearest stellar neighbor, Proxima Centauri. By second 6, you've already passed Barnard's star. At the 40-second mark, you arrive at the TRAPPIST-1 system. Looking at this diagram, planets E, F, and G fall squarely in the habitable zone, making them some of our best candidates for Earth-like conditions. You leave them behind instantly. 7 hours and 13 minutes into your flight, you reach the center of the Milky Way. This glowing, blurred ring of light is Sagittarius A star, the supermassive black hole anchoring our entire galaxy. Leaving the Milky Way, you enter the emptiness of intergalactic space. 29 days into your journey, this massive spiral structure fills your window. You've reached our galactic neighbor, Andromeda. You've been flying for a month. You've crossed the void between individual galaxies. Sitting in the pilot seat, it feels like the entire universe is yours to map, but the scale is about to shift. You spend the next few months crossing the local group, a collection of over 80 distinct galaxies. At 1 year and 9 months, you've reached the Virgo cluster. Our local group is a tiny speck within this massive web. Zoom out further. The Virgo cluster is just a localized neighborhood inside the Virgo supercluster, a tier containing thousands of smaller clusters. To cross the full span of the Laniakea supercluster, the wider structure that contains Virgo, you have to fly at 1 light year per second for over 16 solid years. You are a quarter of the way through your life. You are traveling at an impossible, godlike speed. And yet, you are still stuck inside your own local cosmic neighborhood. Beyond the clusters lie the macro structures of the cosmos. The universe is mostly made up of galactic voids, unimaginably vast, empty bed zones with virtually no stars or light. Take the LOES North Void. Flying straight through it at 1 light year per second, you would sit in absolute pitch-black isolation for 94 continuous years. Bordering these voids are the massive counterstructures known as galactic filaments or Great Walls. The largest we know of is the Hercules Corona Borealis Great Wall. Crossing this single wall takes 317 years. The mathematics are absolute. Your 60-year lifespan runs out before you even make a dent in this structure. The thought experiment ends in failure. You die of old age having seen less than 10% of the universe. The physical limits of the human body are completely incompatible with the true scale of space. Let's remove the biological limit. If your ghost kept flying, crossing the entirety of the observable universe, the 93 billion light-year bubble we can actually see would take you nearly 100 centuries. This visual shows our observable bubble, but a 2011 statistical estimate suggests the actual universe is at least 250 times larger than what we can see. Crossing that entire span at 1 light-year per second would take 737,000 years, and even that number is incredibly small. In 1983, physicists Stephen Hawking and James Hartley introduced the no-boundary proposal, describing a universe that is finite but has no edges. Their estimated size calculation stretches math to its breaking point. They describe a span of 10 to the power of 10 to the power of 10 to the power of 122 light years. That number is so large, it defeats our capacity to write it. If you took every single atom in the observable universe and wrote 1 billion zeros on each of them, you still wouldn't come close to writing the full number of zeros required to describe this size. The universe is completely immune to human conquest. We can invent machines that break the speed of light, and we still can't escape our own neighborhood. Our tiny corner of reality is the only thing we will ever truly know.